Out of curiosity, how many of you participated in our rocketry mini-conf last year? Yeah, good to see all of you again. Hope you've been having fun. And if you happen to have picked up telemetrum boards from me and have them here today, after I'm done talking, come find me and we'll get updates done. I want to give everyone here a little bit of an update on some of the things that have happened to telemetrum, which is the, not as nonprofit as it used to be, that Keith and I are running to build bits and pieces of cool embedded stuff that's being used in the high-powered model rocketry hobby. But then, surprisingly enough, that now actually has a tighter connection with Arduino stuff than has been the case in the past. So it actually almost makes sense to be talking about that some here, and you'll see what I mean. But then there's one other thing that I've been working on recently that I couldn't help throwing in a little bit. Those of you who came and heard my main conference talk last year about converting the big milling machine over to the CNC will recall that I said I was having some slight wigginesses with the little FPGA board I was using to drive the servos. And so this is the first prototype just recently put together of a board that has a big FPGA and a bunch of connectors on it, not a lot else. But this is completely open hardware design, open source implementation of a 4-channel high-power servo control board for use with EMC2. And as soon as I get back from the conference and from FOSDEM and have a chance to catch my breath a little bit, I'll finish debugging this, and if it works out okay, as you can tell, I went nuts. It's a 4-layer board. It's designed for maximum noise immunity and all that kind of stuff. And if it works out okay, I'll be offering those for sale through my website too. But enough about that. If you're curious about this, feel free to come talk to me about it later in the week. Okay, so telemetrum. It's been a crazy year. During the latter half of the year, we reorganized telemetrum. Instead of just being a .org, it's now an LLC, which in US lingo means it's a limited liability company, sort of in between a privately owned company and a full corporation. And the reason for that was primarily to keep our accountants happy, but it's kind of weird now to have like a real company, telemetrum. And Keith Packard and I remain the principals, and everything we do is still 100% open hardware and open source stuff, but we are just selling enough of it now that the accountants would like us to be a little more organized about the paperwork. Telemetrum, which is the rocket flight computer that we were using last year, many of us in the projects we built in the rocketry mini-conf, when we showed up here at LCA, the very first version 1.1 boards were brought down here and flown by some of the folks that were involved in that mini-conf. By the end of the year, that production run had sold out. So we now have a couple hundred board sets of telemetrum flight computers out in the high-power model rocketry hobby community, and that's been really cool. Late in the 1.1 cycle, we started getting these occasional reports from customers that had bought the boards that they were seeing spontaneous resets during flight. And to make a long story short, we realized that we over-optimized the design and took out one more bypass cap than we really should have. And it is entirely possible to get enough RF noise into the input of the low dropout voltage regulator to cause its output to droop just enough to trip the reset controller on those boards, at which point you get a non-harmful to anything except maybe the rocket, depending on where you are in flight, reset of the microprocessor. The good news is we're not aware of anybody that actually lost an airframe to this bug, but they certainly had situations where after putting out the parachutes, because by the way, when you're firing the pyro ejection charge is the time where this is most likely to happen. We had a couple folks where the parachutes would come out and then the board would reset and they'd stop getting the same kind of telemetry they'd been getting, and it was sort of confusing. So we put out a big lengthy blog post about this problem and how we triaged it, and offered to all of our existing customers with 1.1 boards that at no charge we'd be happy to update them. And that's what I was offering earlier. I've got enough parts here to fix that. If folks are interested in more details about that, feel free to ask me. Version 1.2 is out, and there's two things that are changed from 1.1. The first is the RF immunity fixes are all there. The second is that we were victims of the Japanese earthquake in a big way. It turns out that Freescale's MEMS accelerometer line was in the Sendai facility, and that building got pancaked. So right now today, you cannot get Freescale's accelerometers. They're just gone. all stock of anything. Well, except there's some guy in the Bay Area that is offering to sell you a few parts for a ridiculous price, but there's always somebody like that on the market. And so we had to change accelerometer vendors. We're using an Analog Devices 70G part that works just great. But that was an unexpected need to rev the board, which I wasn't counting on having to go through. And that, as a result, meant that for the second year in a row, we were all out of stock going into the Christmas buying season, which was not great. But those are all out now. They work great, and they're for sale if anybody wants one. I have a couple with me. The Telemini is a new flight computer that we came out with this year. The telemetrum board's a lot of fun, but we were interested in doing something that was less expensive and could plausibly be used in even smaller rockets. That's a photo of the board, and because it's hard to convey the sense of scale, this is one of them which I'll pass around. That's small enough it'll fit inside an SD standard 18 millimeter rocket airframe. And the compromise is that we give up all the sensors except the baro pressure sensor, and that means the firmware had to get more intelligent because we're actually estimating velocity and acceleration during flight using just the baro readings. So that this board will happily do flights past Mach without needing to have lockout settings and all that sort of stuff. And that's all thanks to the crazy amount of time that Keith puts into the firmware. The microcontroller in this, for those of you who don't recall, is an 8051 core with 32K of flash and 4K RAM. And at any given moment, we're within a few bytes of being out of flash. And every time we want to add a new feature, we have to go figure out how to get more clever about something that's already there. But I mean, I'm serious, but this is kind of the fun part of working with microcontroller stuff, right? There have been a couple times in the last year where Keith has sort of paused and asked me if he's thanked me enough times recently for designing toys just for him. And I think given what he does for a day job, the fact that he gets to work on things like this where he can, as one person, wrap his brain around the entire problem is part of the excitement. So anyway, Telemini's kind of cool. It's in the market. We're selling them. There are rocketry people who love them and others who just can't figure it out. There's no switches, no jumpers. You talk to the thing over the radio all the time, and that freaks some people out, but they're pretty cool. However, because that board is so small, it didn't have enough physical space for me to put something like a USB connector on it. We don't have any way on that board to charge the lithium polymer battery, so I was motivated to design a really cute, even smaller lithium polymer battery charging board. I'm still hand loading all the ones of these that I make and sell, which is why I didn't bring huge piles of them with me. I was tempted to bring enough to just hand them out, but that's a dual rate charger. It'll do 100 milliamp or 500 milliamp charge rate from a micro USB to the standard 2-pin, 2mm JST connectors that are all on all of the lithium polymer batteries we use. And I think it's really cool. The coolest feature is the charging chip that I chose actually gives us enough state output that I've got a tiny little dual LED mounted on there. And what's driven me crazy in the past with a lot of battery chargers is, you get one LED that tells you if it's charging or not, but if the light's not on, what does that really mean? Does it mean the battery's fully charged? Does it mean you tripped over the cord and it's not actually charging at all? And so this gives you a positive indication of charge completion. And if both LEDs are on, which actually looks kind of yellow because the red and green being close together kind of looks yellow, that's your warning that something is wrong somewhere. And not a big deal, but just the kind of stuff we've done this year, sort of half for fun and half because we needed it to fill a gap in what else we were doing. So then what I really wanted to talk about today are companion boards. And the idea with a companion board is that when we designed the telemetrum altimeter for the rockets, we put a connector on it that was intended for adding expansion boards. We call those companion boards. And I'll talk a little bit about what's on that interface in just a sec. But from the very beginning, I've had this notion that I'd like to have a lot more pyro channels for doing complex flights, either having rockets that ignited additional motors after launch or had more complex deployment schemes or whatever. And so this board called Telepyro is one that I've had in my head for a long time and only recently actually got around to making. This is it. You can pass one of these around to you. That's a Telepyro board. Now, one of the things that's kind of interesting, you'll notice the processor choice on this. Those of you who've actually looked at the little board that was in your attendees packet this year will notice that it's the same processor chip. And I was highly amused when I discovered that, because now all of you have development hardware for building companion boards. And the flip side of that is that if you want to try out Altos, which is Keith's little cooperative multitasking environment with thread support and all this stuff that we actually use as the basis for all of our flight code and companion board code, there is a port of that for the ATmega32U4 that's in our source tree. It's all GPL v2. Feel free to grab a copy, take a look. There's even an internals doc now explaining sort of how Altos works and where to find the bits and pieces of it that you're welcome to take a look at and do whatever you'd like. The other interesting thing that happened is about a year and a half ago, my son and I were at a big rocket launch, and a good friend of ours, Adrian Adamson, was on the flight line right next to us. He's kind of a crazy altitude nut, and he does all these custom, absolutely minimum size rockets to fly sort of monstrously huge motors in. And he had a very small custom carbon fiber airframe that he flew on a 38 millimeter diameter J-class motor to something like 23,000 feet. It's the most amazing thing I've ever seen. And when that rocket came back, it had gotten hot enough, because I think, if I remember correctly, that kissed Mach 3. The carbon fiber that he'd built it out of, the epoxy had gotten hot enough that it had bubbled some, and the carbon fiber fabric was starting to delaminate. My son took one look at it, stared at it, and turned to me and said, "Hey, Dad, this is because it got really hot, right?" And I said, "Yes." And he thought about it a little bit longer, and he said, "Could we build a rocket to see how hot that gets?" It's like, well, gee, when you have a 12-year-old ask you questions like that, what do? You design a companion board. And this one has the ability to support up to 12 NTC thermistors. There's a particular EPCOS thermistor I discovered that's glass bead 0.8 of a millimeter in diameter. So they have very little thermal inertia, and you can mount them right out sort of in the edges of fins and up the sides of nose cones and stuff like that. And we built several of these boards as prototypes, and we flew a couple of them at the Large Dangerous Rocket Ships launch this year. Unfortunately, we had a mechanical failure of the coupler behind the nose cone at Mach 0.97 when we hit a little bit of crosswind and burned the rest of the propellant going sideways. So not as much cool data to report as I'd like, but this is an example of another board we've done. I think I would eventually, there's been a lot of interest in this from school groups and so forth, so I think eventually that one may get added to the product list. The problem, of course, is I designed it with the thermistor amplifiers very carefully designed and tuned for that one model of EPCOS thermistor, and I don't know that that's what everybody would want to use, so got to kind of figure out what to do with that. But those are the two examples of specific companion boards so far that I've designed. For those of you who haven't seen them coming around yet, that's a telepyro board, and it really is fairly simple. Micro USB on all of these for programming and talking to the ATmega32U4. There are 4 dual FETs down here. This one happens to have a 3-axis magnetic sensor on it, but not so great for rockets. Don't think we'll fly that again. And I did put the 6-pin AVR programming header on there as well, because at the time we were building these, we hadn't quite sussed out the flashing over USB thing, and that requires a bootloader, and well, anyway, you understand. So that's telepyro, and then this is telescience. Very similar electrically, though mechanically quite different. In this case, it's got the 12 analog input buffering channels, which have op-amp thermistor conditioning circuits on them as well. And yes, all of these prototypes are ones that I continue to load by hand at home. All the passives are 0402 size surface mount. Let me tell you, I hate resistors. You have to get them right side up. You can't put the black side down. And there are 116 or something resistors on this board. I load them in batches of 3, and I'm usually about ready to kill myself or somebody else by the time I'm done. So when you see those, yeah, dear daughter here knows. What's that? What package of the resistors? They are 0402? Yeah, 0402s. And well, so I mean, the funny story is when I first started working with the TI ChipCon RF system on chip that we use for a lot of stuff, they made it very clear that if you wanted to get the best performance out of the RF filter section, you had to do it in 0402 or smaller. because otherwise the geometry of the traces gets to be too big. Well, anyway, if you want good RF performance, that's what you do. And now on about the 5th rev of the circuit boards, I'm actually getting better RF output on all of my boards than TI's reference designs, which is really cool. So we've got that dialed in and working really well. But the consequence of that is I kind of got in the habit of using 0402. And so that CNCF PGA board is the first thing I've ever designed using surface mount parts bigger than 0402 since my original altimeter board talked about at Melbourne LCA, I guess it was, which used 1206s. So yeah, there's way too much 0402 in my life. And I would do smaller if I could see them. Okay, so companion boards are cool, but we've wanted for a long time to do something a little better. Right now our principal ground station looks like this. This one has a shorter cable than most of the ones I sell, but there's a tiny little board in here that has one of the RF system on chips on it. We use it as a radio to USB interface. We've done a version now called teleBT, which is the same thing, but we added a pre-manufactured Bluetooth module that I found a source for in China that's reasonably cost-effective. And because I want to be able to use this wirelessly, it has to have a battery and the battery charger and all that stuff on it. So this is basically, we call this teleBT. It's basically a teledongle with Bluetooth, and we use it would be used as a Bluetooth to our kind of UHF radio interface. The idea is you'd mount this at the feed point of a little handheld Yagi antenna that you could point at the rocket, and then stand there with your Android phone and the app, which is almost working right, and use that for tracking the rocket in flight. And of course it can also be used with the Bluetooth that's on a laptop or something. It implements the SPP Bluetooth profile, which is the serial port protocol, which means that it'll work for anything except Apple products just fine. Mac OS is okay, but any iPhone or iPad things need not apply because Apple is actively hostile to anyone who wants to develop hardware accessories for those devices. I'll be happy to go into more details later if you'd like. The short version is in the same way that I can't do license-free RF in the US without going nuts, I can't do anything that works with iPhones or iPads without going nuts, and this is supposed to be fun, not nuts, so just not going to do it. And then Teleterra. We had a couple of years ago done, if you go out to our website and look under Teleterra, you'll see photos of the original sort of completely standalone ground station we did. Unfortunately, when we priced it out, we figured out we'd have to sell it for over 400 bucks. And I just couldn't imagine anyone, except maybe me, thinking that was cool enough to buy. And so we backed off, and we kind of forgot about it for a while. Well, we unforgot about it when some very good friends in various rocketry clubs in the US started pestering us about, can't you give us something so we don't have to lug a notebook up and down the flight line? And we didn't really understand what a big deal that was until we actually had a chance to visit some of these launch sites, and we realized that they're always breezy, and they're in the middle of plowed fields, and there's dust everywhere, and notebooks just don't do real well in the windy dust. So I went back and took a look, and by radically simplifying some aspects of the design, giving up on voice synthesis in the handheld unit and things like that, we've got it down to where I think this version we could actually afford to produce and sell. One of the ways I saved money, though, is I got rid of our expensive, relatively, GPS antenna with its amplified patch, and am trying a really small chip GPS antenna. And the tuning on that's a little finicky, and I haven't quite got it right yet, but I'll pass that around as well. So again, for us, these are rocketry things, but this is a TI-CC11 platform that has GPS and radio link and an LCD and a bunch of buttons. In Australia, you are blessed with a sane, I think, RF regulatory process where these can be operated without a license under the low probability of interference device regulations in the frequency band of interest. So unlike in the US, you don't have to have a ham radio license in Australia to use this stuff, though I, of course, encourage everybody to get ham radio licenses because I think it's a brilliant thing to do and a lot of fun. But part of the reason I'm showing this here is these are all open hardware designs, all the schematics, PC board artwork, all the source code for everything is all up on our Git repo behind altusmetrum.org. Feel free to go have a look and borrow from it or use things or tell us if you'd like to buy stuff, and we'll figure that out too. For those of you who haven't seen them come around, this is what a teleBT looks like. And so, again, I don't know. If you want details, I'll be happy to talk about these more. These are all sort of small and part of the and strangely shaped, and it has to do with the fact that there are these translucent blue plastic boxes from Hammond that are sort of our signature thing these days. And so all Altimetrum products that need a box are being designed to fit into one or another of Hammond's cute little blue boxes. I don't actually have a photo of the new version of Teleterra that's coming out, so you'll have to look at that in person. Okay. So what I originally proposed to John that might be fun to talk about today was the fact that we've talked forever about the fact that we ought to do something like a white paper explaining how to use Arduino things as companion boards for telemetrum. Now, that obviously only really matters to people who own some of our telemetrum rocketry goodness, but it seems still like it would be a good thing to do, particularly because there are some school groups that have been very interested in designing their own companion boards. And you get into these lengthy discussions with them and you realize that they don't really want to lay out circuit boards. They want to hack stuff together in the same way that people do a lot with proto shields on Arduino. And for the size projects a lot of these folks are working on, why not? Makes sense. So it turns out that on telemetrum, the companion port is a little 8-pin connector that happens to have SPI, serial peripheral interface bus, with one chip select line at 3.3 volt levels. And it provides both the regulated and unregulated power from the telemetrum board that could be used by the companion. As of version 1.0 of Altos, we radically changed the over-the-radio telemetry protocol to use a fixed packet size, 1 byte of which is used to determine which packet type this is. And a consequence of that is that we were also able to add, finally, support for companion boards that during the power-up process, there's a little protocol that runs over the SPI bus where we interrogate the companion board, find out not only what it is, but how many telemetry channels it would like to offer up and how often it would like to have those sent in the RF downlink. And then those just automatically get folded into the telemetry that's being sent down over the radio. So you can design an arbitrary companion board, tell us that you've got 8 telemetry channels you'd like reported once every 5 seconds, and that just happens. As of this morning, Keith has finished documenting that protocol in supposedly human-readable text, though I haven't read it yet. And as soon as I'm done talking, I'll go back and push the updated copy of the docs out to the repo so that you can find them. Don't look for them right now because they aren't there yet. But with that, anybody who would like to do that, I think now has all the information they need to do it. And again, if you have any questions, feel free to ask about them. So what's this thing called Teleshield about? Well, how many of you were at the Arduino MiniConf last year when I gave a little talk about the greenhouse project we were working on? Yeah, great. My wife has a greenhouse behind our house in Colorado. And you know, it's got a vent fan because in the middle of summer in Colorado at high altitude, the sun is just every bit as harsh, if not worse, than it is in this part of the world. And it gets really hot in there, and you have to run a fan to keep things from wilting and burning up and dying. And at the edges of the seasons, it gets really cold. And so there are heaters that run to do the opposite. And my son got interested in hydroponic things and was talking about wanting to be able to program time, have programmed timers to turn pumps on and off and all that. So being the kind of dad I am, I turned that into an Arduino Shield project. And that's been sort of his project, and so it's stumbled along fairly slowly. We did get to the point where the basic project is complete and seems to do all the things it's supposed to. The relay control stuff's all working and so forth. One of our objectives all along, though, is that Mom would love to be able to do things like find out what temperature it is out in the greenhouse without having to walk out there. And so from the beginning, we talked about using one of the circuit boards from a teledongle to hook things up, but well, yeah, right. So this was the original plan, little SparkFun level shifter board to take the 3.3 volts out of the teledongle. This is the guts of a teledongle. And that connector at the top is the companion connector. And the idea was to interface that to serial or SPI ports, whichever. Oh, by the way, and on the companion port, while I talk about it as being SPI because that's the protocol that we use on telemetrum for talking to companions, those same pins can be used as async serials. So if you're willing to change the firmware on the CC1111, you could also do async over that port. So the plan was going to be to do either async or SPI to the Arduino, but then it's like, well, yeah, but that's kind of a mess. So I ended up designing a shield. And as I said, I kind of went nuts. I used one of the TI TXS Magic level shifting chips, which means that I don't actually care what the voltage level on the attached Arduino is. It just works. It's got one of our style UHF radios implemented using the CC1111 RF system on chip that we use on everything else. Attached to that is a micro USB interface and our standard debug and companion headers. So once again, this shield board, jumpered the right way, can be used powered off of USB, just like a teledongle or a tele-Bluetooth thing. But then we also put the Bluetooth interface on it that we had discovered and are using on our tele-Bluetooth product. And then just because Keith said he needed it for something he was working on, we stuck a micro SD socket on so that you've got some data storage. And that is literally the first prototype, which I got working about a week ago. And because I'm all over making a fool of myself in public, I'm going to turn this on. So what I have right now is I borrowed a lithium polymer battery from Grant because I forgot to bring any with me. This is one of the SparkFun 3.3 volts Arduino Pro 328s or something with the shield stuck on top of it and jumpered to just take its power off of there. And then if what do I have to do? If I do that and then open this up and drag it over. Right, okay, so now I'm talking over the serial port and I'm talking to my teledongle, serial number 100. That's this cute little puppy here. If I then put it into our packet protocol, it should connect, to the other guy. And now I'm talking to that board, and the hello and goodbye world are actually being generated by a sketch running on the Arduino. And so right now I'm just echoing the Arduino serial port through the RF link. And lest you believe I'm cheating or something, I will turn this off. And sure enough, it stops spewing. And when I turn it back on, it's going to reinitialize. And I have to send a keystroke or something at it to wake it up again. Right? Which board am I talking to? I'm talking to Shield again, and there we go. And then the Bluetooth stuff is almost as much fun. Unfortunately, I don't know how to bring this up on the remote display, so bear with me for a second. I'm going to connect to the serial port profile, which brought up dev RFCOM0. And now if I pop and open another terminal window and drag it over here, oh, give me a break. Why is it that half the time when you bring up dev RFCOM0 it does this and the other half the time it doesn't? Let's try a disconnect on that and reconnect and see if that clears it. I guess I should be amazed that this stuff works as well as it does, but there we go, okay. So now there we are talking over Bluetooth, and the really amusing part is that the firmware running in the little shield board right now responds to whoever last had its attention. So if we come over to the UHF link, it's redirecting there. And yeah, thanks. Stupid people tricks, right? So talk about stupid people. About the time I got to this point, I went, oh, great. So the demo I ought to do is we ought to upload a new sketch to the Arduino while I'm standing there. And then I realized that I did the wrong thing with the reset lines, and I need to cut one resistor out and put a FET in so that we can actually pull the Arduino's reset line from our processor. So we may or may not get around to that this week. I'll certainly make that change before I put these into production, if we do in fact put them in production. But I don't know, somehow the notion of being able to reprogram the Arduino over either Bluetooth or a theoretical 30-mile range UHF link, I don't know, it just seems cool to me. So that's Teleshield. By the way, a few minutes, 15 maybe being generous, before we left for the airport to come down here, I took another 3 prototype Teleshields out of the skillet after hand loading and reflowing them. And this morning I cleaned them up and started adding the through-hole parts to them. If we get those turned on, if any of you would like to play with one while you're here this week, feel free to poke me and I will be happy to let you do that. And if you talk to me sweetly enough and cash is involved, you can probably even take one home. So, yeah, you know, what can I say? So let me see, what else did I have in here? That's it, except the obligatory. If you have any other questions or would like to see any of the other things we're doing, please feel free to take a look. As long as I'm passing things around, that's a telemetrum. I don't know that everybody's seen one. Yeah. Yeah, where are they all? Have they made it around the room? Did they get stopped somewhere? I will get them all back before I leave. So yeah, if you'd like to look at the shield, I'll even pass that around. In fact, I'll pass it around running.
You guys see the telemetry? We're about out of time.
Yep, I think we're about out of time. If you have other questions, I'll be around. Please feel free to come up and say hi and ask about them, and I'll be happy to tell you anything you'd like to know. Thanks. Yep.
Okay, we have an afternoon tea break now, so it's about, I think we've got about 25 minutes left of the break, and then starting back here around 3:40 for the next talk.
Slide the switch on the side and just turn that off.
I think they all sort of just ended up there.
Oh, man.
Oh, yeah, grab that.